Hello, my name is Albert Gu. I'm an 8th grader at Marshall Middle School. My project is about early life brain wiring for movement. During early life, neurons in the brain are actively building the connections with the corresponding targets. The development process is crucial for normal functions. We focus on the development of the neural connections between the motor cortex and the striatum. The striatum is an important structure in the brain that regulates movement. It is well known that problems with the striatum is associated with Parkinson's and Huntington's disease. An anterograde fluorescent tracer, which traces the movement of the neurons through the neuronal pathways, DI, is implanted into the motor cortex of rat brains of different postnatal, which means after birth, ages. Here's an example of the location of the dye in the motor cortex right after implantation. This is a week later. You can see that the dye diffuses within the motor cortex. After 2 months, the brains are sectioned with the vibrotome. Here's the brain section. The red spot is the dye tracer. A confocal microscope is used to image the fiber in the stratum. We picked 3 sites to analyze the fiber densities. 9 and 12 o'clock in the contralateral motor cortex. Here are the fibers on P0, the day of birth at 9 o'clock location. P2, the 3rd day of birth. P6, the 7th day of birth. P12, the 13th day of birth. P20, the 21st day of birth. And here are the fibers on P36, the 37th day of birth. The area of the pixels have been tabled and plotted. It is concluded that the connections from the motor cortex to the striatum in the rat brain develop clearly in the time window between P6 and P12. Motor cortex neurons send their axons to the opposite motor cortex via the corpus callosum, a tissue structure that connects the two brain hemispheres at about the same time. Thank you for listening.